All right, class, let's finish up this chapter with right triangle trigonometry. This is really how you probably, most of you have come about to learn about sines and cosines. You started in a right triangle. So I'm going to bring back the first definition I went over in 5.2 on sine and cosine, where we said really you can pick any circle of any radius. And so wherever you land, it has an x and y coordinate. So the sine value of this angle theta is simply y over r, and the cosine value of this angle theta is simply x over r. And then we said to keep things simple, we might as well scale it down to a radius 1, right? A unit circle. And then we don't have to worry about the r, right? We just pick x and y. So when you look at this triangle right here, what is x? X is really this distance, and y is this distance here. So sure enough, x squared plus y squared is the radius squared because you are in a right triangle. So if we were to just grab that triangle out and concentrate on it, then what is again sine? Sine value is, of this angle theta, is y over r. So as you see, it's the opposite leg divided by the hypotenuse. This cosine value of this angle theta is x over r. So really what that boils down to in this triangle, it's simply the adjacent side divided by the hypotenuse. And just to finish our trig function values, at least the three main ones, right? All the others are reciprocals. Tangent is of course the ratio between sine and cosine, which I said that means boils down to r reducing, right? And you have a y over x, which is nothing but the opposite leg divided by the adjacent leg. Okay, so when you have learned about right triangle trigonometry, you might have even learned this mnemonic: so, ka, toa. In other words, what? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so this allows us to solve right triangles. What do I mean by that? To solve right triangles means simply to find all angles and sides. And sometimes we might not even need to find them all. Maybe it's some kind of word problem where we just have to find one side or one angle or a couple of things. But the point is we can use these rules right here to figure out the angles and the sides. Okay, so I'm going to right away get on to solve a right triangle. So usually when you have a right triangle here, I'll draw one for you. Definitely by a right triangle we mean that it's got one right angle, and we label that with a little square. If we put a square on an angle, that means we know it's right. So in a triangle ABC, we usually call C the right angle, and then the opposite sides we label them with lowercase letters. Side A opposite to angle A, side B opposite to angle B, and side C opposite to angle C. So when we might not just draw the triangle, we might say side A is so much, side B is so much. You know that's the setup of a right triangle. So let's say we know that side B might be 10, whatever. Let's not put units on it. Centimeters, feet, whatever you want. Let's say angle B measures 60 degrees. And that's about it. We need to find the rest of them. Now, even though it might look like just two pieces of information, remember what we know is that we have a right triangle, so angle C clearly is the 90-degree angle. We don't have to say that. Okay, so with these three pieces of information, can you find me the rest? Well, easily, since this is a triangle, the angles in a triangle add up to 180. So that's why I'm 50. So angle A easily is 180 minus 90 minus 60. I'll write it out. Of course, you don't have to do that. But angle A clearly is 30 degrees, right? Easily done, right? You know, two angles in a triangle, you can find the third one. Okay, how do I find the rest of it? Well, let's say I'm going to use this angle of 60 degrees, and I know that what? Sine of this angle of 60 degrees, which is our angle B, right, is the opposite, which is 10, divided by the hypotenuse, which we don't know yet, and it's a C. So out of this equation right here, I can cross multiply. Divide by sine of 60, so, and of course some of you can do this in one step. Just swap these two. So 10 divided by the way, sine of 60 is the square root of 3 over 2, right? So that's 20 divided by the square root of 3. Or exact value, 20 square root of 3 over 3. So we found the exact value of C, okay? It's not a big deal. You can put in a calculator and come up with an answer. It didn't ask for an exact value. And finally, I know side B is 10. I know side C is this number here. How do I find side A? It's again, you can use Pythagoras theorem now that you have two of the sides in this right triangle, or you can again use right triangle trigonometry. It's much easier. Cosine of this 60 degrees, right, of this angle B is the adjacent, which is A, divided by the hypotenuse, which we now know is 20 square root of 3 over 3, or here, 20 over square root of, okay, fine. So side A is going to be the product of these. What's cosine of 60 is 1/2. So that's just 10 square root of 3 over 3. So again, exact value. Not a big deal if you would have put them in your calculator and came up with the decimal answers. Okay. So let's solve another right triangle. I'm going to draw for you. Here it is. I'm not even going to draw it. I'm just going to say solve the right triangle. And again, right. By chapter 8, we will learn to solve any type of triangle, so you'll really have to pay attention to see which kind you're dealing with. So if I say side A is 30, angle B is 63, find the rest of them, okay? So what you might want to do is actually want to write or draw this triangle for yourselves in any order you want. But we have an A, B, C, and it doesn't have to be to scale. What do I know? Well, what? Clearly this is 90 degrees. This is 63 degrees. So clearly I can find angle A in a bit. So angle A is the leftover to 90. So that should be what, 27 degrees? Okay. All right, so we found angle A right away. What else do I know? I know side A, which is opposite to angle A, is going to be 30. So what can I use to find the rest? Here, let's just use a tangent for fun, right? Tangent of angle of 63 degrees, or an angle B, is the opposite, which by the way is this side B. You don't have to write B, you can write AC for it, it's fine too. So it's the opposite over adjacent, which is 30. So from here, B is simply 30 times tangent of 63 degrees. So that's going to be about 58 0.88. Okay. And what else do I need? I need the hypotenuse. So again, you can use this side B that you found to be 58.88 and use Pythagoras theorem. What we like to do though is use, this is already a rounded off number, right? And if you use that to get another number you're going to round off, you're going to get even further away from your answer. So as much as you can, especially since there's so many connections, you should try and use given exact information, like this 63-degree angle and the 30 whatever unit sides. So cosine of 60 degrees is the adjacent, which is 30, over the hypotenuse, which is what we're trying to find. So this is why it helps so much to in fact draw this triangle, because you see which one's the adjacent. If you've labeled all the sides, it makes it much easier for you to figure all this out. So putting this in your calculator, you'll get 66.08 approximately. Okay, makes sense. It's the hypotenuse, should be the longest side. All perfect, all done. Okay, let's try some wordy problems. So, if you look in your book, problem 48, I'm going to tell you what it says. It says that there's a person in the window of a building, and it looks across at a different building that we know is 200 feet high. So I'm drawing this story for you. Okay. So here's a person in the window of this building. We don't know how high in the building he is, but he looks across in the distance and he sees this building of 200 feet. Great. Now, what he knows, he measures that the angle of elevation, and I'll tell you in a minute what an angle of elevation is, but the angle of elevation to the top of the building is 15 degrees, and the angle of depression to the bottom of the building is 2 degrees. Okay? So knowing this, could you find how far away is this building from where this guy is in the window? Okay, so what's the distance between the two buildings? Okay, so let me tell you first of all what an angle of elevation is and what an angle of depression is. An angle of elevation is always an angle made from the horizontal line side up, and an angle of depression is an angle made from the horizontal down. So as you see, this is the horizontal line side. Maybe someone sitting there or standing there. These are his eyes, right? This is his line side. And then with his vision raised, he looks up at something and can immediately measure that angle of elevation. So the point is that an angle of elevation is always made with the horizontal, and that's a common mistake for students to make. It's not an angle with a vertical line, it's always with the horizontal line side. So if you look up, it's an angle of elevation. If you look down, it's an angle of depression, right? Okay, and again, you might have already learned this in your trig classes, should have. Okay, anyhow. All right, so Here's this building. The person in the window looks up to the top of the building, sees 15 degrees. 15 degrees with what? With the horizontal line side. Yes, so straight up. And then the angle of depression to the bottom of the building is 2 degrees. And we want to find this distance. So, sure enough, the horizontal should make a 90-degree angle with the building if it stands up straight. So we have two right triangles here. What do we know in these two right triangles? We know an angle, right? And that's about it. But what we know is that this little piece from here up plus this little piece in the second triangle is 200. Now the thing is, we cannot absolutely use the big triangle, right? Where this would be the 200 feet side. Why? Because this is not a right triangle, right? So we have to piece it together from here. And if you want, I can call this a y1 and a y2. And definitely what I know is that y1 plus y2 is equal to 200. Yes? And how do I find this y1? I'm going to write it here on the side just next to the picture. So what puts together this, of course, the x that I need to find and the 15-degree angle. It's going to be a tangent, yes? So tangent of 15 degrees is the opposite over the adjacent. So from here, easily, y1 is going to be equal to x times tangent of 15 degrees. And the same thing, tangent of 2 degrees, right? This angle of elevation is the opposite, which is this y2 over the adjacent x. So y2 is equal to x times tangent of 2 degrees, right? Okay, so what did I say? I said that y1 plus y2, these two pieces will have to add up to 200 feet, yes? So that's an x times tangent of 15 degrees plus an x times tangent of 2 degrees equals to 200. And that's a beautiful equation in x. Solving for this, we found that distance. Now, put these numbers in your calculator. You can factor out the x and divide and put it in your calculator once. I'm going to keep things simple. And I'm going to put in the calculator first. So tangent of 15 degrees is 0.2679. Tangent of 2 degrees is 0.0349. So you might be wondering how many decimal places. Maybe it's same as with the log. 4 decimal places would be good for this. 2 is fine as well. That's not a big deal. But of course, the more decimal places we keep, the closer. Don't put more than 4. It's a big waste of time. 2 are enough. If you want to be a little bit more accurate, fine, pick 4. So add these up. That's going to be a 0.3028 many x's divided out of 200, right? So x is going to be about 660.5 feet. And again, this could be very much rounded off. If you, again, what else could you have done, as I said? You could have factored out this x. And in your calculator, just simply put 200 divided by tangent of 15 plus tangent of 2. Make sure your calculator is in degree mode, yes. And make sure you put these in a parentheses, or else your calculator will only divide by tangent of 15, so that's not a good thing. Okay. All right. Let's see. Yeah, we can continue. And here's problem 52. And it's a story about a ladder that leans up on a side of a building. So always draw a picture. So it says a ladder leans up on a side of a building. And the ladder is 33 feet long. And it says the ladder makes an 18-degree angle with the side with the horizontal. So there's your 18-degree angle, right? The question is, how high up the side of the building does the ladder reach? So again, we assume that this building is perpendicular to the ground, yes. And there it is. So what's going to put together this angle? The 33-foot ladder, and this, how high does it reach up the side of the building? That's definitely a sine, right? Oops, 80, not 18. So sine of 80 degrees is the opposite over the hypotenuse, which is 33. So again, drawing the pictures key to it all. So cross multiply, x is simply 33 times sine of 80 degrees, which is, put in your calculator, about 32.5. And again, these being word problems, you definitely need to label the sides. Okay, so I'm going to take a break for now, bring in more problems, and we'll do a few more in the next video.